All right, math leaguers, how we doing today? All right, coming at you from my kitchen again because St. Margaret of York, where my classroom is kind of working really hard to get set up for this weekend's Smoy Fest. So if you're a Smoy person or if you're one of my other folks from one of the other schools, come on, I got to put in a plug. Come on out to the Smoy Festival this Friday, July 28th, or Saturday or Sunday. And enjoy. Maybe I'll get a chance to see you there. Maybe we can even convince Miss Tanya to bring some of her special Mr. T's Math League t-shirts and have them there if you happen to run across one of us. All right, next, I'm just going to start you off. This is the wrap-up. If you're new to this thing, each week we kind of go through a few problems that might have been tricky. We wrap up the week's questions, and we also have a joke of the week. The jokes are horrible, but they are math related. All right, so I'm going to go ahead and start with the joke. I got this one here. I got a little picture. We got a little boy who walks up to the tree, and the boy says, "Well, Mr. Tree, how tall are you?" And the tree says, "Well, gee, I don't know. I'm just a tree, right?" And then the little boy says, "Well, how many leaves do you have?" And the tree says, "Well, I don't know. Gee, I'm just a tree." And the little boy says, "Well, how could I find the circumference of your trunk?" And the big tree says, "Gee, I'm a tree." "Gee, I'm a tree, geometry." I told you the jokes are awful, all right? For those of you that were here for session 1, you got spared some of the worst jokes. And for those of you that are parents, you want to hear some good math jokes, I'm at Valley Vineyards, first Wednesday of every month, doing a little stand-up, and I do quite a long bit about the quadratic formula. But don't bring your kids. The other comedians there are dirty. So, all right. All right, next, I wanted to go over a couple of the problems. I'm going to go ahead and do this one first. You guys, a lot of people submitted their answers. By the way, if you haven't submitted your answers, just try to get them in on Sundays and send them to that other email, that tarnowskip746@gmail.com email. But the question was number 10. There was some guy or a girl who played a game, and they flipped a coin, and then they rolled a die, singular for dice, and they won if they got I think it was a heads on the coin, or they also won if they got a certain number on the die, like I forget what it was, a 3 or 5 or something, but just one number, right? And so normally what we would think, if there's 2 ways to win, you would add together the probabilities, but that's actually not true. Because if you think about it, if there was, like let's say you rolled 2 dice, and you could win by getting anything other than a 1 on the first die, and then anything other than a 2 on the second die, well, you have a 5 out of 6 chance to win, and a 5 out of 6 chance to win. If you added them together, that would mean you'd have a better than 100% chance to win, which is not possible, right? Because you could lose. It is possible. It's not strong, but it is possible you could lose. So that's how you do this problem. You figure out the probability of losing. So the probability of losing is, if you wanted a head, you could get a tails. And if you wanted to get like a 3 on the die, you could get something else, one of the other 5 things. And you multiply the probability. So it'd be like tails not 3. So it'd be a half times 5/6, which is 5/12. So that's the chance of losing. So all the other probabilities would be winners. 7 out of 12. Okay? All right, so there's that one. I wanted to do number 2 And number 3, I got here on this whiteboard. All right, so there's a special formula. It said that the guy had like 8 friends, and he wanted to give them, and he had 5 sticks of gum, so he had to pass them out, right? So the way I like to do it is to say, look, here's the first stick of gum. How many people could he give it to? 8 different people, because he's got 8 friends. And it says he's only giving 1 stick to a person, so he's not like doubling up, right? So the second stick could go to 7 different people. The third stick could go to 6 people. 4th stick could go to 5 people. And the 5th stick could go to 4 people, because these guys already have 1, okay? And then you multiply all those, and that's the many different ways we could rearrange the ways he's giving out the sticks. But if you think about it, if he gave a stick of gum to Al, Bob, Chris, Dave, and Ed, all right, these are actually counting for all the ways he could give them out, such as he could give his first stick to Al and his second stick to Bob, or he could give his first stick to Bob and his second stick to Al, and there's all these different ways of rearranging the same 5 people, but that doesn't matter because it's the same 5 people get a stick of gum. So those are called combinations, okay? And actually it's funny, like when somebody says, do your locker combination, the locker combination, it shouldn't be called a combination, because in a locker, when you do your combination, the order actually matters. But it's like saying the word combination actually means, like, if your combo is 10, 15, 35, if you use the word combination properly, it means you could do 35, 10, 15, and it would still work, but that's not right. What you're really doing is your locker permutation. Talk about that in a minute. So anyway, that's too many ways, right? Because it's the same 5 people getting the same stick of gum. So we have to divide out all the ways we could rearrange the 5 people. And, well, we could have this guy in the first slot, this guy in the second slot, this guy in the third slot, this guy in the 4th slot, this guy in the 5th slot. So we could rearrange them this many ways, okay? By the way, 5 times 4 times 3 times 2 times 1 is called 5 factorial. It's written with an exclamation point. That's what it means. Like 4 factorial is 4 times 3 times 2 times 1. This is not 8 factorial. It's similar, but it would have to go all the way down to 1. Anyway, we could do a little fancy division, right? The 5 and the 4s cancel out. The 3 and 2 cancels the 6. And the answer was 56. 56 ways that these people could get their gum. Now, for this one, oh, I forgot to show you. There's a special formula. Sorry. Special formula. A combinations of B is A factorial over B factorial times A minus B factorial. Pretty fancy. All it really is doing this using fancy letters and words and stuff like that. It's 8, the 8 combinations of 5 would be 8 factorial, which is going all the way down to 3, 2, 1. We would divide out the 3 factorial, okay, and that would just get us down to the 8, 7, 6, 5, 4, and then we divide out the 5 factorial, okay? Now here, it's permutations, because in the next question, it said there are different flavors of gum. And so for the different flavors of gum, like Al could get the green, Bob could get the red, or Al could get the red and Bob could get the green. So there are different ways of rearranging those same people, so we don't divide them all out. Okay, so literally it's permutations. It's just 8 factorial divided by 8 minus 5 factorial, which is 8 factorial over 3 factorial, which is 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 divided by 3 times 2 times 1, which is that. Okay, which is the original thing we had when we did our little slots thing, right? 8 for the first stick of gum, for the yellow stick of gum. 7 for the red stick, 6, 5, 4. And we don't have to divide out because they all count. Because we could rearrange who gets which piece of gum. A little complicated, but not too bad. All right, and then, let's see, I also wanted to do number 16. Sorry, I got number 16 here. I hope you guys can see these. Number 16, it says 20% of A is 50% of B. And then it wants you to say what percent is A, or A is what percent of B. Okay, so again, if we don't know what the numbers are, you can kind of just start off, and we're just doing a comparison. So make up a number. Pretend A is 100. That's the easiest number. 20% of 100 is 20. Okay, 20 is 50% of B. Well, 20 is half of B, so B must be 40. So if A is 100, then B is 40. So A compared to B, A is what percent of B? So you divide 100 over 40, which is 2.5, which is 250%. I apologize. I don't know why I put on the answer sheet that it should come out as a decimal, like that you should write it as a decimal. I guess you should have put 250.0%, but if you didn't, that's fine. I didn't mean to write that. I think it was part of another problem that I was copying. So anyway, that was that one. And then finally, number 18, that was kind of cool. It said 14 to the 5th power minus 14 to the 3rd power is equal to 14 to the what power times 195. Now, you could easily just do this. You could do it on a calculator, all right? And kind of guess and check and figure it out. But there's a little cool trick. If you know the distributive property, 14 to the 3rd power, which is 14 times 14 times 14, fits into 14 to the 5th power, and it also fits into 14 to the 3rd power. It's called factoring out. In my class, we call it slurping out. But what you can do is you can pull this 14 to the 3rd, because it goes into both, out here, and you could say 14 to the 3rd times 14 to the 2nd is 14 to the 5th, right? 14 times 14 times 14 times 14 times 14 is 14 to the 5th power. And then 14 to the 3rd power times 1 is 14 to the 3rd power. Now, a quick little thing here, I always encourage my kids to know their squares. Their first 20 squares, 14 squared is 196, minus 1 is 195. So it's 14 to the 3rd times 195, and that was the question. 14 to the what times 195 is equal to this. Would you have known to do that? Probably not. You learned in math to like play around with things, try tricks that you know and see if they work. All right, and that's it. Let's have a great week 2. Great week 2, and I hope we see some of you up at the festival. Have a good day.